Hello everybody, in this video we will talk about scalar products. So what is a scalar product and how it is different from a normal product or a normal multiplication process. As we have talked about vectors, as we have heard about vectors and the algebra of vectors, we had discussed about how to find sum of vectors, how to find difference of vectors and all. But algebra is not about only sum and difference, it's more than that. So in this video, we will talk about multiplication of vectors. So also we know that what is the result of multiplication? I mean outcome. Multiplication of vector results in product, and there are two types of product in case of vectors. The first is dot product and the second one is cross product. The nature of dot product is scalar, that's why it is sometimes referred as scalar product. But the nature of cross product is vector and it is also referred as vector product. So in this video we will talk about dot product or scalar product. Now, let's talk about dot product. Like two vectors A and B, then dot product or scalar product is defined as A dot B equals magnitude of A, magnitude of B, and cos theta, where theta is the angle between the vectors A and B. We can see it geometrically as well. Let's see. Suppose we have vectors A and B, and the angle between these vectors is theta. This one is vector A and this one is vector B. Then if we will take the projection of vector B on A, this one is the projection of angle B or vector B on vector A, and it would be equal to B cos theta. This is the projection of vector B on vector A. So now it can be imagined as it's the component of vector B in direction of vector A, that is B cos theta. That's so we can easily define it as A dot B can be given as vector A, I mean magnitude of vector A, and magnitude of vector B in the direction of vector A, that is equal to B cos theta. So it looks quite simple. It is also said as projection of vector B, or it's the component of B in direction of A. Also we can write it as, suppose if it is vector A and this one is vector B and the angle between them is theta, then we can write this as A cos theta. It's projection of vector A on B and it's in direction of B. So here we can see that we are taking the component of vector A in direction of vector B, and again it can be written as A dot B equals to A cos theta. It's the component of vector A in direction of vector B and magnitude of vector B. So it's quite simple. We can see that we can represent it in the form of projections of vector A and B and a magnitude of another vector. So it's quite simple. Here is a very good example of a dot product or a scalar product of two vectors where we have taken vector A and vector B, which is given as ax I cap, ayj cap plus az k cap, and vector B is given as bx I cap, byj cap, and bz k cap. Let's find out A dot B. So it's like normal multiplication. You have to multiply these with these. So it's more like this. Now ax with bx gives us ax bx, and then I cap dot I cap. then it would be right ax bx I cap j cap, then ax bz I cap k cap. Similarly, we will get more terms with ay bx j cap I cap plus ay by j cap plus ay bz j cap k cap plus az bx k cap I cap plus az by k cap j cap plus az bz k cap. So here we can see that it's I dot I cap dot I cap I got I dot sorry I cap dot j cap I dot sorry I cap dot k cap. So here are the unit vectors, and we are getting the dot product of unit vectors. We know that it's the unit vector for x direction, and there are two unit vectors of x direction, and we also know that the angle between these two is 0. And if you would see I dot, it would be like magnitude of I dot into magnitude of I dot times cos theta, and we have already found that the angle between unit vector of in x direction is 0 degree. That means it would be going to it would become 1. And we also know that the value of unit vectors, the magnitude of unit vectors is 1. 1 times 1 gives us 1. Similarly, j cap dot j cap will give us 1, k cap dot k cap will give us 1. And if it would be different, like I cap dot j cap, so the angle between these is 90 degree, and the cos 90 would give us 0. Hence the entire term would be 0. If I cap dot j cap equals to j cap dot k cap equals to k cap dot I cap, it would all result in 0. From here we can see that the terms with different unit vectors will be cancelled out. Sorry, which this will become 0. Like I am pointing out these terms, and these will result in 1, 1, 1. Hence the entire thing will finally become like ax bx plus ay by plus az vz. So if when you have to find dot product, you would just take the x component of this with this and write it down, y component of this with this and write it down, and z component of this with this and write it down. So it's very simple. You got it. Let's do an example. So let's consider a very typical question, which is vector A equals 4 I cap plus 3 j cap plus 5 k cap, and vector B equals 3 I cap plus 5 j cap plus 3 k cap, and we have to find the dot product of vector A and vector B. And we know that we can simply write it down as x component of A vector with x component of B vector, that is 4 times 3 plus y component of A vector times y component of B vector plus z component of A vector and z component of B vector. 4 3 is 2, 3 5 is 15, and 5 3 is 15. It would result in 42 units. And the second question is the theta between A and B, that means angle between A and B. And we know that A dot B equals magnitude of A, magnitude of B, and cos theta. So cos theta would be equal to A dot B divided by magnitude of A and magnitude of B. So we already know that A dot B gives us 42, and now we have to find out the magnitude of A and B. Magnitude of A would be equal to under root 4 square plus 3 square plus 5 square. That would be 16, 9, 25, and plus 25 root under root 50. And magnitude of B would be equal to 9 plus 25 plus 9. 18 plus 25, how much it is it? Okay, it's like 43 units. So it would be like 50 times 43, and that's your cos theta. So theta would be cos inverse 42 upon under root 50 times 4, it's 43. So that's your theta between vector A and vector B. And that's the end of this video. We will have more videos. This one was the first one, so we will bring more videos and we'll do very great problems of physics and mathematics on this channel. So give it a thumbs up and support me.